Very good morning. So today we'll start uh, aromatic, anti-aromatic, non-aromatic. So first we discussed Hückel's rule. So Hückel's was a scientist gave the rule to find the aromaticity. So first we'll see the Hückel's rule. So let us see. According to the Hückel's rule, according to the Hückel's rule, a a compound compound said to be aromatic if it satisfy satisfy 4n plus 2 rule. Okay, so obviously Huckles gives the rule. If any compound satisfy 4n plus 2 rule, then it is called the aromatic compound. So first we'll discuss aromatic, then anti-aromatic, then non-aromatic. So first heading is aromatic. Aromatic. Let us see what is the aromatic. So we have a 4 rule to satisfy aromaticity. So first one is A is should be cyclic. Compound should be cyclic. Then second one is conjugation. Conjugation or conjugated. Conjugated means alternate pi bond is present, like pi, sigma, pi. Or next one is it can be pi sigma lone pair. It can be pi sigma lone pair, and another is yes, of course, pi sigma charge. Charge can be positive or negative. Yes, of course. So and third one is should be planar. Compound should be planar. Okay, compound should be planar. And last one is for aromaticity, it satisfies 4n plus 2 pi electrons. 4n plus 2 pi electrons. Okay, so if you put n equals to 0, you will get how much? 2 pi electrons. If you put n equals to 1, you will get the 6 pi electrons. 6 pi electrons. Okay, 6 pi electrons. That means if you put n equals to 2, so you'll get the 10 pi electrons. Like that, you can check. Okay, so this is the condition for aromatic compound. Let us see for anti-aromatic. For anti-aromatic. Okay, you can write it A dot A in short. Okay. Okay, so same process, it should be cyclic. Second, conjugation, all the things is same, and also planar, except fourth rule. That means it satisfies 4 and pi electrons. Okay, so if you put n equals to 0, what happen? Obviously n equals to 0, this is all about 0, so there are no conjugation, so rules second is not satisfied, so that it start from n equals to 1, not 0. Keep in mind. Okay, so n equals to 1, then n equals to 2. If n equals to 1, you get the 4 pi electrons. N equals to 2, 8 pi electrons. Like that, it is satisfied. Okay, clear? Yes. Then move to the non-aromatic. Non-aromatic. Obviously, non-aromatic, which is not aromatic and neither be anti-aromatic. That means neither be aromatic nor be anti-aromatic. Anti-aromatic is called the non-aromatic. I think clear. Okay, so let us see the stability order. What is the order of stability? So very easy. You know that basically aromatic is more stable. Aromatic is more stable than non-aromatic. I'm writing N dot A. Non-aromatic. Then last anti-aromatic. Anti-aromatic. This is the order of stability of the compound. More stable is aromatic, then non-aromatic, then lastly anti-aromatic. Clear? So I think theory part is covered. Let us see some example to understand more about what is the how to determine aromatic, anti-aromatic, and non-aromatic. Okay, so let us see the examples. So first example, this one you can check the aromaticity. Okay, so you have to first check the rules. First rule is should be cyclic. Yes, compound is cyclic. Very good. Then conjugation. Conjugation is basically pi sigma sigma. There is no any conjugation. Pi sigma sigma. Pi is not present alternate, and pi sigma lone pair is also not there. Okay, no another charge is alternately present here. So conjugation ccp rules is not conjugation is not satisfied. Obviously then it is non-aromatic. Very easy. Yes, you can do it. Okay, then move to the next example, like this pi bond and positive charge is there. This one is the first one, and this one is the second one example. So if you check, yes, cyclic is this ring. Okay. Then conjugation, yes, pi sigma charge sigma pi. Whole the ring, it satisfied the conjugation. Pi, look, this one is the pi sigma, then charge sigma pi. Okay, whole the ring is conjugation. Obviously, conjugation is present. Planar, you can judge. Yes, if carbon, mostly we have to see that if carbon is sp2, we have generally tell the planarity. Okay, okay. Directly we can't determine the planarity of the compound. Okay, so this rule is satisfied. Then we have to check the 4n plus 2 rule. 4n plus 2 pi electrons. If I'm put, this is 2 pi electrons is present in this compound. So if I'm putting n equals to 0, you'll get the 2 pi electrons. So obviously this is satisfy this rule also. So it is aromatic because it satisfy all the rule. Okay, clear? Then move to the next example. The third one is like I'm taking this one. Okay, so you have to check first cyclic. Yes, cyclic is this. Then conjugation pi sigma pi sigma pi. Obviously conjugation is also planarity. Carbon is sp2. Obviously it is planar is also. What about 4n plus 2 pi electrons? So we have a 4 pi electrons here. 2, 1, 2, 3, 4 pi electrons, obviously. So, it satisfies 4 and pi electrons. If you put n equals to 1, okay, you'll get the 4 pi electrons. So, obviously, it satisfies the anti-aromaticity. Anti-aromaticity. Clear? I think clear everyone. So let us see more example. Like if I'm taking another example, this one, and there are some positive charges present. Let us see what is this compound. So pi, sigma, charge, sigma, sigma. Obviously, cyclic is there, but conjugation is disturbed. Sigma sigma present, so conjugation is not present. So obviously this is non-aromatic. Non-aromatic. Okay. What about this? What about this? Okay. What about this compound? Negative means that means they have a some lone pair is present. Okay. So lone pair is also contribution in conjugation. So what happened? Obviously, you see cyclic is this, conjugation is satisfied pi sigma, charge sigma pi. Very good. Conjugation is also there. Then move to the total. There is 6 pi electrons. How? This is also contribution in the conjugation. That then it is also pi electrons. Okay, so 2 to 4 to 6 pi electrons. So which rule is satisfied? It satisfies 4 and plus 2 pi electrons. So if you put n equals to 1, you'll get the 6 pi electrons. That means it satisfies planar T is also. So it is satisfies CCP and 4 and plus 2 pi electrons also. So obviously it is aromatic. Aromatic. Okay, clear. So take one more example. So if I'm taking this one, this one pi sigma sigma, obviously conjugation is there, but sorry, cyclic is there, conjugation is not present because continuously 2 sigma bond is present, so conjugation is not possible, so it is non-aromatic. So see one more example. This one. Okay, so obviously pi sigma charge sigma pi sigma sigma, so continuously here present sigma sigma, that's why it is not satisfied. Cyclic is this, but conjugation it is not satisfied, so obviously it is not aromatic. Okay, move to the next example. That means this one is the, I think, 7. Next 8. If I'm just adding charge on these two position, like there are some negative, there are some positive charge on this one. What happened? So just increase one positive charge, it satisfies cyclic conjugation pi sigma charge sigma pi sigma charge. That means conjugation is also, planar is also, it satisfies how much electrons is there, so 2 to 4 to 6 pi electrons. That means it is satisfy 4 and plus 2 pi electrons. Okay, if you put n equals to 1, you'll get the 6 pi electrons, so obviously it satisfies all the rule, so it is aromatic. So it is aromatic. Okay, so move to the next example. Okay, so this is period, this is pyrrole. Okay, this is pyrrole. So if you check the pi sigma, first you see the cyclic is this, conjugation pi sigma lone pair, then sigma pi, obviously conjugation is also there, planarity is also. So you know that basically it satisfy how much electrons contribution in conjugation, 6 pi electrons. How this electrons is also, this lone pairs is also contribution, that means 6 pi electron, that means it satisfy 4 and plus 2 pi electrons. So if you put n equals to 1, you'll get the 6 pi electrons, that is it is aromatic. Take one another example, 9 10. Okay, So if I'm taking this example at Rosen, okay, this is pyridine. What pyridine? Okay, just wait. This one is the pyridine. So if you see pi, sigma, pi, this lone pair is not participate in conjugation. Why? Because already pi, sigma, pi is present. So this lone pairs is not participate in conjugation. So obviously 6 pi electrons is there. So conjugation, cyclic conjugation is also there. Planar is also, it satisfies 4 and plus 2 pi electrons. So obviously it is aromatic. What is importance of this? This lone pair is not participate in the conjugation. So it is just act as a base and good base. Why? Because it donates lone pair. Okay, so it is good base as compared to pyrrole. Pyrrole have not it is this pyrrole have a lone pair is participate in the conjugation, so that's why this is not good base. But obviously pyridine is good base. I think clear everyone. So I'm taking one more example, 11 number, double bond. What about this? How to find the aromaticity? So you know that this compound carbon is connected directly oxygen, and you know that oxygen is more electron negative as compared to carbon. This one is the carbon, obviously. So this oxygen is more powerful, then this is attracted electron pair. So electron pair is shifted here. Okay, so what happened? So it looks like, just wait. Okay, it's look like this way. Negative charge, obviously electrons is shifted oxygen, it becomes a deficiency of electron, positive charge. Now you can check the aromaticity. You know that the pi sigma charge, sigma pi is present, obviously conjugation cyclic planar is also okay. So it have a 2 pi electrons, 2 pi electrons is present here. Okay, so satisfy 4n plus 2 pi electrons. Okay, if you put n equals to 0, so obviously it is aromatic. It is aromatic. Clear everyone? Very easy? Yes, very easy. So let us see more example. So example number, I think 10 or 11. Okay, whatever it is. Okay, so if I'm taking this one, double bond. Okay, okay, this one. So this carbon is directly connected to oxygen. Oxygen is more electron negative, so it attracts the electron pair. Electron pair is shifted to the oxygen. What happened? Yes, this double bond, double bond. Sorry, oxygen is present here. So there O minus O positive. So cyclic is there. So pi sigma charge, sigma lone pair. That means conjugation is there. Planar is also. So you have to see how many electrons. 2, 2, 2, 4, 4, 2, 6. This lone pair is also contributing conjugation, resonance. Okay, so it is also considered 2 pi electrons. So it becomes total 6 pi electrons. So obviously it satisfies 4n plus 2 pi electrons. Okay, so if you put n equals to 1, you will get the 6 pi electrons. So this is also aromatic. This is also aromatic. Then example number 12. Okay, not good. Let us try to one more time. Okay, now fine. Okay, this one, you have to check this one. So obviously you know that this is cyclic conjugation. Yes, pi sigma charge, sigma pi sigma charge, sigma pi in whole ring conjugation is there. Planar is also 6 pi electrons is there. Okay, so it is also aromatic. It satisfies 4n plus 2 pi electrons. If you put n equals to 1, you will get the 6 pi electrons. That is aromatic compound. Aromatic compound. Okay. So let us see more example. Multi-ring. Okay. Discuss multi-ring. In multi-ring, bicyclotype compound. Bi, sorry, bicyclo. Okay. So let us see the examples. So example, if I'm taking example number how much when numbering I don't know. So let us see. So if I'm taking bicyclotype compound, this one, okay. So this is called the naphthalene. Naphthalene. Let us see naphthalene. Okay. So naphthalene. Okay. So let us see the aromaticity. First cyclic is this conjugation. You can check pi sigma pi sigma pi sigma pi sigma pi sigma pi. Okay, so conjugation is also there. Planarity is also. You have to check the total number of pi electrons. 6 to 8, 10 pi electrons. That means it satisfies 4n plus 2 pi electrons. If you put n equals to 2, you'll get the 10 pi electrons. That means this one is the aromatic. Move to the next example. Okay, like this one. This is called anthracene. What? Anthracene. Okay, so obviously cyclic is satisfied. Conjugation is also. You can check pi sigma pi sigma. All the have a pi bond is present. Alternate. So conjugation is also there. What about planarity? Yes, planar is this compound. Okay, so count total number of pi electrons. Six to 6 to this is one is the 6 4 10 10 4 14 pi electrons. Okay, so that means it satisfies 4n plus 2 pi electrons. If you put n equals to how much? 3. 4 3s are 12 plus 2. Okay, so it becomes 14 pi electrons. Obviously it is also aromatic. Okay, clear? Let us see the biphenyl type compound. Biphenyl type compound. Biphenyl, you know that two ring. Okay, okay. So this is biphenyl type compound. If you see this compound, this is obviously cyclic. Conjugation is also there. Planar is also there. If you combine this and count the total pi electrons, you'll get 6 6 12 pi electrons. Okay, obviously 12 pi electrons means it satisfies 4 and pi electrons if you and put n equals to 3. Okay, so it becomes anti-aromatic, which is unstable, which is unstable. But if you see the individual compound, if you see individual compound, this compound 6 pi electrons is satisfied. This compound is also 6 pi electrons is satisfied. 4n plus 2 pi electrons. Follow the rule. aromaticity. That means this individual is aromatic, this individual is also aromatic. If you combine these two aromatic, it becomes whole aromatic. Okay, it becomes whole aromatic. That means it satisfies the aromaticity. It is not anti-aromatic, it is unstable. That's why aromatic is stable. Okay, clear? Biphenyl, I think clear everyone. So let us see more example. So it clears more. Okay, so let us see dimerization. Just wait. Okay. Dimerization. Okay. So dimerization means if I'm taking the compound, this compound and another this compound. Okay. So you know that this one is the satisfy. Obviously, cyclic conjugation is also there, planar is also, but condition satisfy anti-aromatic, which is individually it is anti-aromatic, which is obviously unstable, which is unstable. You know that. So if we have doing something, that means this compound uh, makes it is stable. How? So let us see, this pi electrons is shifted here. Sorry. Okay, this pi electrons shifted here, one, and this one another, and this another, and this one is another. Okay, what happened? These electrons make the bond. Obviously it make the bond, and this pi electrons is break. So it is just like that. Okay, so obviously this one making one electrons, this one electrons, this one electrons, this one electrons make the bond. So if you check this, you know that this is a non-cyclic compound, no any pi bond is present. So non-cyclic, that means it not satisfies cyclicity. Okay, that's why cyclic is this. But obviously what happened, conjugation is not present. Okay, sorry, conjugation is not present. So if conjugation is not present, so obviously it is non-aromatic, and we know that non-aromatic compound is more stable as compared to the anti-aromatic compound. Okay, this compound makes more stable itself. Okay, clear? Okay, then move to the next reaction with reaction with metal. Reaction with metal. So like you know that sodium, potassium, all the metals, sodium, potassium, iron. Okay. So if you know these metals have a loses electrons easily. So if I'm taking example, this one and taking 2 moles of sodium. What happened? So you know that basically this sodium is losses electrons. It becomes N plus, Na plus and 1 electrons. And another sodium is also losses electrons. It becomes Na plus, then another 1 electrons. That means it loses 2 electrons. And what happened? This is breaking bond, single bond. So arrow is one sided. Okay. So it looks like 1 electrons, and 1 electrons of this sodium, another electrons of this sodium, like that. Okay. So this paired of electrons means it participate in conjugation. So it is also count in pi electrons. So obviously cyclic is this. You know that this one is the anti-aromatic compound. Why? Because it satisfies 4 and pi electrons. Okay, it satisfies 4 and pi electrons. so that it is anti-aromatic. So obviously, so total conjugation is there, obviously conjugation is also there, planar is also. So total electrons becomes pi electrons, 6 pi electrons. Why? Because to this lone pair, this 2 4 and to this 6. Yeah. So obviously what happened? So it is satisfied 4n plus 2 pi electrons. If you put n equals to 1, you'll get the 6 pi electron. That means this time it is aromatic. Anti-aromatic, which is least stable, unstable. If you convert it is aromatic, then this compound have a more stable. This one is the unstable to more stable. Okay, you know that each and every things to make it more stable. Okay, in universe. Okay, so let us see one more example. Okay, like I'm taking Br and Az plus. Okay, so what happened when you have see this reaction? What happened? This bromine is more electron negative, so it attracts the electron of the carbon. Okay, so what happened? What happened? You can see this pi electrons, this pi electrons, this pi electrons. If you remove the bromine, it becomes positive charge, and Az plus it becomes, after the removing it becomes Br minus. So Ag plus and Br minus makes the Az Br. Okay, if you check the it is cyclic, yes, cyclic is this. Then conjugation, yes, pi sigma, pi sigma, pi sigma charge, sigma pi sigma pi. Okay, so it satisfies whole ring, cyclic as well as conjugation. Planar is also. So look, there are 6 pi electrons, so it satisfy 4n plus 2 pi electrons should if you put n equals to 1. Okay, so obviously it is also aromatic compound. So I think we have covered lots of example in the aromatic, anti-aromatic and non-aromatic. I think all are understood the concept of the anti-aromatic, non-aromatic and aromatic. Okay, so thank you so much everyone. So I'm ending the class. Bye to all.